As a bubble rises, it causes pulp to flow around it and a wake to form behind it. This is represented by flow stream lines. This flow will tend to deflect particles and reduce the probability of collision. The probability of collision is the number of particles that actually collide relative to the number in the path of the bubble. This probability is surprisingly small. One bubble may collide with fewer than 1 in 100 of the particles in its path. As a consequence, a large number of bubbles must be produced. Larger particles are less influenced by pulp flow streamlines and are more likely to collide with a bubble. Here, 2 particles of the same mineral are in the path of a rising bubble. The larger particle is not deflected as much as the small one. The result is that the large particle collides and the small one does not. The contact time is the time it takes a particle to slide around a bubble. The speed at which a particle slides depends mainly on its weight. Here, 2 particles of the same mineral collide with a bubble. The larger particle slides faster and doesn't have time to attach. When a hydrophobic particle collides with a bubble and slides along its surface, it begins to penetrate the water film. To attach, the particle must penetrate this layer. The time it takes for this to occur is called the induction time. Induction time decreases with increasing particle hydrophobicity. If the induction time is longer than the contact time, the particle will not attach. A second process, attachment, discriminates between hydrophobic particles and hydrophilic ones. Here, 2 particles, one hydrophilic and one hydrophobic, are in the path and collide with a rising bubble. The hydrophobic particle is able to break through the water film on the bubble and attach. The hydrophilic particle slides along the bubble until it reaches the bottom, at which point it eventually falls away. With increasing particle size, the collision probability increases and the attachment probability decreases. The combined effect is that collection probability tends to be highest at intermediate size ranges. This corresponds to a common flotation plant observation that as particle size increases, collection reaches a maximum over a certain size range and then decreases.